mentioned, these are the double doors that are locked as restricted access. We have about 7,000 square feet of lab space. All our labs here will kind of go in and discuss. We also have a lab down at the marina on the park. So the marina building right there, half of it is lab space where we can actually bring in water from the bay and do kind of more realistic type of experiments. So we can go ahead, we'll head into the culture lab here. Come on in. So one of the most important research projects that we work on every year for the last 10 years now is monitoring the water quality, especially on our swimming beaches. So EPA mandates that to get a swimming beach, you have to test it at least once per week for bacterial levels. So you probably maybe have heard of E. coli. That's the bacteria that we monitor for. That's what EPA says, you know, that's your indicator species. That's the bacteria that you want to test for. And if it's so high, then you have to issue what is called an advisory on your beach. So you tell the public, you know, there's an highly aseptic techniques that I'm not going to demonstrate right now. But we use forceps that are sterilized. We take out this piece of filter paper right here. We place it on top of the funnel. We have another glass piece here. We pour the water in there, and as the water goes through this filter paper, the pore size, or the gaps in between the paper threads there, is 0.47 micrometers, so itty bitty tiny. And it lets the water through, but it captures the bacteria in here. And so once we pour it through, we turn on that pump, it creates a vacuum. We open up the valve there. We open up the valve, the water gets sucked through, all the water goes up. So all the bacteria is captured on this filter paper. And then we take the filter paper up and we put it on this petri dish. And in the bottom of this petri dish is this yellow, jello-looking stuff. It's media or nutrients to help the bacteria grow. So it feeds the bacteria. Interestingly, this nutrient media, this agar, is very specific where it grows E. coli, specifically just E. coli. And when it grows, it gives color to the E. coli colonies, so it makes them dark purple. So we filter it, we put it on here, we incubate it in our incubator over there, and our incubator behind it looks like a refrigerator, and then we come in the next day, and we pull the plates out, and we see a bunch of purple dots on it, and we count the number of dots, and we figure out how many colonies. Each dot represents one bacteria. So when we put it on here, it was one bacteria, and then as we incubated it, that bacteria grew and grew into a colony, or a dot that we can see. So then we count all those colonies, and we figure out the number of colony-forming units per 100 milliliters of water. So
roast duck.
Yes, they come with our water baths. So we have these big water baths that we put our plates in to incubate them, and they come with it. I thought they turned colors when it got hot enough. But yeah, they're
that one just collapsed.
That one, yeah, he's been around for a while. He needs to go. But yeah, if you were to come out here anytime between Memorial Day and Labor Day, this lab would be very busy. We have interns running water in their little lab jackets, and you know, we hire college students to do it. So, and it's not glamorous work. I mean, it's kind of doing the same thing every day and then prepping for the next day. But, you know, and I try to explain it like it is summer and it's really nice and you're going to be stuck inside.
Well, no, not that at all.
I know, my first stop's not very good. The doors are actually too heavy. Every time I get a door stop, like heavy duty one. Okay, this is our chemistry lab, and you'll see most of our labs were designed as T-tracks that we built right here. It has rebar and weights on the bottom to make sure it sinks on the bottom. There would be floats on the top, and also the wood helps it float. And we would have a camera, GoPro, mounted right here. And what we are researching is looking at yellow perch. So I don't know if you guys go yellow perch fishing, but by the end of the season, the yellow perch have migrated out to about like 50, 60 some feet of water. And when you bring them up from 60 feet, they go through what we term acute decompression sickness. So their swim bladder expands because all of that pressure of 60 feet of water is no longer on them. So the swim bladder expands, pushes on their stomach, and pushes their stomach up. Any other questions? This is kind of our chemistry fish lab. All right, we will head back down. And then anybody that did not get a buoy card, you can take one and pass it on, give it to your friends or whatever.
Around their feet and their neck so that they can't swim very good. Not a good look. No.